Hello, everybody. The disorder I chose to do my research on was isovaleric acidemia, also known as IVA for short. And this disorder is caused by a mutation in the IVD gene, which essentially deactivates it, making it unable to provide instructions to produce isovalerial CoA dehydrogenase, which is an enzyme that's responsible for the breakdown of the amino acid leucine. Upon deactivation, it will cause a deficiency um, in the production of the IVD enzyme, which causes a buildup of isovaleric acid and as well as other toxic compounds in the body, which will cause damage to the nervous system and as well as lead to other serious health problems. So one characteristic for this disorder is odor of sweaty feet, which is caused by the buildup of isovaleric acid in the body, essentially. Another characteristic of this disorder is aversion to protein-rich foods, as well as lethargy and vomiting, which is commonly found at presentation after birth. So the molecular cause of this disorder. So essentially, there are mutations that occur in the codon region of the gene, which lead to a abnormally spliced mRNA species in the fibroblasts. And the mutations that are commonly found in individuals with this disorder include missense, nonsense mutations, splicing mutation, and frame shifts. So, yeah, basically, the splicing deactivates this gene and it prevents the production of isovaleric CoA dehydrogenase, which is responsible for the catalyzing in the third step of leucine catabolism. So essentially, the IVD gene converts isovalerial CoA to 3-methylcrotonil CoA, which prevents the buildup of organic acids in the blood. So this is an autosomal recessive gene, or sorry, autosomal recessive disorder. Um, so in order for the individual to be affected with this disorder, they must be homozygous with the recessive allele, which is inherited from both parents. So this is a pedigree that illustrates the inheritance pattern of my disorder. As you can see, uh, Jerry here is exhibiting the recessive trait because he is homozygous with the recessive allele, which is represented here as two lowercase s's. And Marianne, the wife, is heterozygous with one dominant uh, allele and one recessive allele. So the probability that their children will exhibit the recessive trait is 1/2, and the other half will the other half will be carriers. Um, yeah. So and their children, so C and D, will not have any children that exhibit the recessive trait, because as you can see here, James is homozygous with two dominant alleles, whereas Mary is homozygous with two recessive alleles, and so on and so forth. Um, Sam and Diane, E and F, will have one child with the that exhibit the recessive trait. Because you can see here, Sam is heterozygous, one dominant, one recessive, and they're both heterozygous, one dominant, one recessive. So that will lead to one child exhibiting the recessive trait. And yeah, Brian and Leela. Brian is homozygous with a recessive allele, and Leela is homozygous with the dominant allele. So um, none of their children will be affected with the disorder. And Michael and Trisha will have one child with the that will exhibit the recessive trait. Um, yeah. And as for testing options, there are a few that I listed here. Um, the IVD prenatal sequence analysis, the isovaleric acidemia via the IVD gene, the isovaleric acidemia, which include the deletion duplication analysis of the IVD gene, the IVD sequence analysis, the IVD complete sequencing, and the newborn testing. So with the prenatal testing, it occurs in the first or second trimester, um, uh, and the testing. Sorry, it's optional. It's optional, and the testing requires amniocytes, which is obtained from the acquisition of the amniotic fluid that surrounds the fetus, which may result in miscarriages. The newborn screening, testing is typically done on the blood sample that's taken from the heel prick of the baby when they are about 2 to 3 days old, and this testing is mandated in certain states, although the exact set of required tests differ from state to state. They can also do a hearing test, which is conducted to measure the baby's response to sound, as well as skin tests uh, to measure the level of oxygen in the blood. And this can tell if the baby has a congenital heart defect. And that looks like it's about it. Okay, and these are the references. Thank you.